Soil acidity is measured using a pH meter. The pH meter is the scale which values 1 to 14. And the middle, that is 7, is a neutral point. As you climb the ladder to 14, you have the salt affected soils. Below 7, you have the acid soils. The extreme value, the lowest value, is the strongest soil acidity. It is measured with the concentration of hydrogen ion, a logarithmic value, which means between the two values, there is a concentration 100 times bigger. When you find soil pH 6, you drop to 5, you increase by 100 values. In Tanzania, we have big areas that are affected by soil acidity. It is a natural phenomenon that is born of the rocks, dead weathers. If the rock is acidic, it produces acidic soil. That is why you find in the national park, the woodland, that is not cultivated at all, but they have low soil pH, they have high acid soils. Now look, there is a difference between low pH and high pH. When you say low pH, you are talking of smaller values in the scale. So when you say low pH soil, you are saying strong acid soils. In Tanzania, we have about 32.7 million hectares of the land that are affected by soil acidity. And out of that, the cultivated land is 4.7 million hectares. And from that, 1.1 million hectares cultivate the staple food maize. So it is really affecting us. The natural causes of soil acidity, apart from the parent material and rocks, is also attributed or caused by high rainfall. So in Tanzania, the high rainfall areas, all high rainfall areas, are characterized by low pH soil or acidic soils. Those are all the regions of the Southern Highland, including Mbeya, Songwe, Njombe, Iringa, Katavi, Rukwa, Songea, but also all the regions around Lake Victoria that experiences a high rainfall, like Kagera, Kigoma, Mwanza, Mara. But you also find some areas with low pH soil in the other part of the country. So, although the big chunks of the acid soils are found in the regions I have just mentioned, there are also acid soils in other regions of the country. The problem of soil acidity, as I said, this is a measure of hydrogen ion concentration in the solution of soil. When you have low pH soil, that is when you have acid soils, most of the bases, calcium, magnesium, potassium, are not in that solution. They are in low levels and they are not available for plant uptake. As we know, for the crop to do better, they have to have nutrients. The most nutrients that are affected by low pH soils are bases, but also nitrogen and phosphorus. Phosphorus in low pH soils are fixed by the elements that are usually dissolved in the low pH soil, especially aluminium, manganese, and iron. They fix phosphorus and make it unavailable for plant uptake. If phosphorus is not available, it affects the rooting system, it affects the crop establishment. if the bases, like the one I mentioned, calcium, magnesium, potassium, if they are not available, the crop will not sprout or grow in a healthy way. So you have stunted crops, you have poor crops, you have little grains, and you have, at last, a poor yield. That is the implication, because it is the pH that influence availability of the nutrient in the soil for the crop. Soil pH affects almost all crops.
All crops.
Except tea.
Except tea.
Except tea.
Why?
Tea prefer soils with low pH, even the 3. It is sprout, and the quality of tea is prefers the low pH soil. But the crop like maize, beans, wheat, name it, the major crops require the soil pH between 5.5 and 7.5. And because that is the range where most of the nutrients are balanced, they are available in the soil solution. I didn't do research per commodity, but I can just give you an impression. Think that you have 1.1 million hectares that grow maize, and because of the low pH, you end up getting 2 bags of 100 kg per kg per hectare. If you can just find, and you know that in 1 hectare you are supposed to get 25 bags, but because of the soil acidity, you get 2 bags, 3 bags, 5 bags instead of 25, 30. You can see the gap or the loss you are getting. That is one. But another thing, when you have low pH soil, when you apply fertilizers, the fertilizers are not well taken up by the crop. You get off losing up to 70% of what you are applying. Which means if you are investing 100 for fertilizer, you are losing 70 shillings for each 100 you invest in the low acid soil. Which means you can compute using the government subsidy. You can take the billions that are being applied in those soils, and then you just take 50 to 70% as a loss. So it is contributing yield losses, but also for monetary losses. The magnitude is very high, and it's a silent killer. That is why it was not earlier recognized. So the government, you find the government is putting a strong hand on subsidy and what in fertilizers, but leaving behind what could make the fertilizers produce more. Lime is an amendment. It is not part of the fertilizer, but it's not subsidized. As I said, this is a silent problem. It is not that people are not willing to fight this. The people lately came to realization that this is a problem. It is just being realized this is a problem. For the developed world, that is the known fact. But for us, we are just recognizing, even ourselves, even most of the scientists are just realizing it now. And the government also started to realize it. And the government composed a team that explored it in 2017. That is when the problem got into perspective. The help is there.
How?
The help is just to accept that is the problem we are living in. We need to establish correctly the extent of it, and because we know the antidote, we know what corrects the problem, we go for it. There is no shortcut. because it's a natural phenomenon that existed before even we start cultivating the land.
So, if I can just try to digest what you've been telling me so far, there's nothing human beings contributed to it.
Their contribution of a human being.
How?
We contribute through farming practices.
Farming practices.
Farming practices in Tanzania in particular. We plant crops and then we harvest the whole thing. We harvest the grain and through anymore we harvest the rest. It means you are continuously harvesting the bases. Mind you, the calcium, the potassium, the phosphorus, name it, get in the plant from the soil. The more you plant, the frequency of planting is the frequency of harvesting what is in the soil. And it gets depleted. That is very natural. In that, you keep on taking, pumping out. You take to the market, you export abroad, but you leave undesirable soil properties, the aluminium, the manganese, the iron. So the continuous cultivation intensifies acidity. That is one thing. Another thing that is not applicable in our country is the application of nitrogenous fertilizers that also have a contribution of acidifying. But because our use of fertilizers is minimal, that may not hold in our country. We are using very little fertilizers. But in other countries, in every bag of fertilizer you apply with a certain amount of lime to neutralize the acidification effect of the fertilizers. In our case, that is not yet. I don't think it is true. The government, although I am not a spokesman of the government,
I know, but you are a professional on this. But I think you know some strategies which are being implemented or whatever, so that we can counter this problem.
The government of Tanzania have started a huge soil testing. And when you test the soil, you know what is the problem of the soil. And when you know the problem, you will go for the problem. That is one strategy that I find it to be a longer heading if towards the soil liming strategy. Because the government is putting a lot of effort in soil testing, the problems emerge, will be obvious, and certainly they will look for the problem.
Are we alone?
They will look for the problem, they will look for the solution of the problem.
Are we alone?
We are not alone.
We are not alone.
We are not alone because there are development partners, there are NGOs, there are many stakeholders out there who are helping the farmers even to realize the problem. I understand this problem came to realization through NGOs like Clinton Foundation. There are other NGOs like Britain and whatnot, One Acre Fund, and many others in the Southern Highland that are helping people to apply lime and see the effect. And that is where we, even scientists, got to know that we had a problem that we were sitting with without knowing it. Gaia is the project, and actually the Gaia is called Guiding Acid Soil Investment in Africa. It is the project that was born out of the project that preceded it, the African Soil Information Service, and the Tanzania Soil Information Service. We did characterization of soils in 18 regions, and we realized this problem. Then we wrote a small project. Then it was realized that this is a regional project, a regional problem. So the idea from Tanzania was expounded to Ethiopia, Rwanda, and Kenya. So this project was being implemented in 4 countries. The aim, apart from advocating healthy soils, is to establish the ground facts, but also to work out and find out the policies that are being implemented by governments aiming to address the problem of soil acidity. In Tanzania, we are doing experiments in 2 districts, Mbozi and Gaia. We had what we call the shotgun trials, 50 trials per district. Each of them, we are trying to establish the facts. How much light do you need? How do you apply for the 2 crops, maize and beans? And I am the national coordinator for the Gaia project. Gaia, we did a purposeful decision to go to Gaia because 45% of the acid soils is located in the lake zone and the western zone. 30% is in the southern highland and south. While there was some kind of awareness in the southern highland, there was no awareness at all around the lake zone. So we did a purposeful selection of that site. As I'm speaking with you now, we have 100 farmers who registered their name, they need light, and they are ready to buy it. So there is awareness creation, but also we have established the losses the farmers are incurring by not using light.